We are still in section 5.4. This is video number 3 in section 5.4, and this one's going to be about angle of elevation and angle of depression. So when we're dealing with right triangles and we're dealing with applications, real story problems, the first thing is that the initial side of either the angle of elevation or the angle of depression has to be horizontal. It must be horizontal. Each of these angles is going to be measured between the line of sight and the horizontal line. Your terminal side is going to be found, if your terminal side is rotating clockwise, it's rotating down, then this is going to be an angle of depression. If your terminal side is found by rotating counterclockwise or up, then it's going to be an angle of elevation. But still notice, both of these, the initial side is at the horizontal. A lot of times I like to put it on the positive x-axis. All right, a how-to on these. Actually, this how-to is identical to the how-to for solving right triangles. You want to draw. Step 2, use a sketch to write an equation. And then step 3, solve your equation and make sure that your answer makes sense. It is absolutely critical that you draw a correct picture. If your picture is not correct, then you're never going to be able to get any of the answers correct. All right, so the first thing that we're going to do, what's going to take the longest on this particular video is just simply drawing the pictures. The math you'll be able to do easily. It'll just simply be the pictures that are a little harder to draw. All right, so this example here, we've got an angle of elevation. So that means that automatically I'm going to be, I'm going to start on my horizontal. And I'm going to go upwards. So there's my angle of elevation. And I got that by reading the first 4 words of this question. Now, where does the angle of elevation go from? Okay, so it has the word from here. From a point on the ground. Okay, so this point right here, this is the origination of my angle of elevation. This is where it goes from. So it goes from a point on the ground, 15.5 meters from the base of a tree to the top of the tree. Okay, and that angle is 60.4 degrees. Now, let's back up a little bit and let's reread that. If my angle of elevation goes from somewhere, it also has to go to somewhere. So go and find the word to. My angle of elevation goes from a point on the ground to the top of a tree. So this here has to be the top of my tree because this is where my angle of elevation goes to. So let's go ahead then and draw the top of your tree. I know, great artwork. Okay, so my angle of elevation goes from a point on the ground to the top of a tree. Now, what does it say in the middle there? It says that the point on the ground is 15.5 meters from the base of the tree. So we've got here, this is 15.5 meters. My angle of elevation is 60.4 degrees. And I'm asked to find the height of the tree. So I'm going to use a different color here. I want to know what is the height of my tree. And this forms a right angle. We're going to assume that the tree is standing up straight. Now, if you'll take a look, you've got an angle to focus on. You have a side that you know. You have a side that you want to know. Look at these 3, look at the relationship of these 3, and decide what kind of an equation can I write using those 3 items. Well, I can use tangent, because tangent is opposite over adjacent. I can multiply on both sides by 15.5. I can throw that into my calculator, and I'm going to get 27.2849. But think about the numbers that I've been given. Both of these have sig digs of 3 units. So we're going to reduce, or not reduce, but round to 27.3 meters. All right, next, we're going to look at an angle of depression. So you have the angle of depression from the top. Okay, so there's that word from again. From the top of a 97-foot building to, there's the word to the base of a building across the street located 42 feet away. All right, so let's go back to the beginning and let's just look right here. We're looking for an angle of depression. So let's draw it first. Angle of depression has to start at the horizontal. It's going to go down, because that's what an angle of depression does. And it's going to form our angle. Let me erase just a little bit of that because I've already kind of marked that. All right. Now, where is this angle of depression going from? It's going from the top of a 97-foot building. Okay, so my building is a bit crooked. It looks more like the Leaning Tower of Pisa. So there's my building. Okay, it's got a window in it, got a door in it so it can get in. Okay. My angle of depression goes from the top of the 97-foot building. Oh, let's put 97 in. To the base of a building across the street. All right, so let's get our building across the street. Window. Door. And how far away is this building across the street? Well, it's located 42 feet away. Okay. All right. Sorry about that. Just cleaning up a little bit. Okay, so I'm looking for the angle of depression. Now, problem number one is that my angle is not inside my triangle. So there's actually two ways that I can look at this. One way is to just form another triangle. If I formed another triangle, that looked like this. Well, I know that this would be 97 over here, and this guy up here would be 42, and all of a sudden my theta is inside my triangle. That's one option. A second option, though, would be to remember something from high school geometry. Do you remember alternate interior angles? Where these guys are always congruent or they're always equal to each other? If that's the case, then my theta up at the top is going to be the same as my theta down here at the bottom. And now my theta is on the inside. All right, so let's set up an equation. Again, if you focus on theta, you'll notice that my sides form opposites and adjacents, which is going to be tangent. Hey, just because I'm using tangent twice in a row doesn't mean we always use tangent. So we'll set up the equation. Tangent is equal to tangent of theta equals 97 over 42. What finds angles? Inverses find angles, so I'll rewrite that as an inverse. I'll throw that into my calculator, and I'll get 66 point something degrees, or we could put it in DMS. But please notice that my numbers here are given with 2 sig digs. So that means that my final answer is going to be 67 degrees. Because remember that your answer cannot be any more accurate than what you were given in the first place.